In this video, we are going to start on a new topic, looking at the atom. We are going to look at the different models that led to the discovery of the atom. What is an atom? An atom is the basic building block of matter. It is the basis of all the structures and organisms in the universe. So basically everything that you see in the universe is made up of different atoms. You can think of the planet, the sun, grass, trees, the air that we breathe, and even people. We're all made up of different combinations of atoms. The elements in the periodic table are arranged in order of increasing atomic number in the periods and groups. We're going to see that when we start looking at the periodic table in chapter 4. There is clearly a relationship between the atomic structure of an element and its position on the periodic table. And again, we're going to see this relationship as we look at the periodic table. Here is a timeline of discoveries leading to atomic models, and you need to know these discoveries and the discoverers. For example, you need to know that John Dalton came up with the billiard ball model, which stated that an atom is just a solid sphere. So John Dalton suggested that an atom cannot be created or destroyed or divided any further in a chemical reaction, and that atoms of a specific element are identical and that they combine in simple ratios to form new substances. And that is Dalton's model on the right that you see there, the solid sphere, the sphere that you see there. That is the atom according to Dalton. And you also need to know that J.J. Thomson or Joseph J. Thomson came up with the plum pudding model, in which he said that atoms contain oppositely charged particles, electrons and protons, and electrons are negatively charged and protons are positively charged. And then he said that atoms are composed of a positive mass in which electrons are embedded, and that is his model on the right. Marie Curie came up with the theory of radioactivity. Ernest Rutherford came up with his model based on his gold foil experiment that he performed. We are going to look at the gold foil experiment. And he said that small positive atomic nucleus with an electron orbiting model. So that was his model. And then Niels Bohr came up with the planetary atomic model, which is mostly used today. In his model, the electrons move around the nucleus in fixed energy levels with particular energies. And then James Chadwick discovered the neutron, which basically changed most of the models. It changed the way at which scientists actually looked at an atom. So what is an atomic model exactly? A model is just a representation of a system in the real world. So a model helps us understand systems and their properties. It is not the actual representation of a particular system. So an atomic model actually represents what an atom could look like, not what an atom actually looks like. So it represents what an atom could look like based on what we already know about the behavior of atoms. So we study atoms, how they behave, and then we come up with a model based on what we have learned. And models are often simplified and they cannot be absolutely accurate. As you will see as we go on with these models, you will see that most of the models, they were incomplete until some things were discovered, and then they tried to complete the atomic model. So don't be surprised when you see an atomic model that is not so relevant. That is because it just represents what an atom could look like. And there were things that were not discovered at that time that those models were made. Let us look at Dalton's atomic model. So Dalton proposed that all matter is made up of very small things, which he called atoms. And during this time, Dalton proposed his atomic model. Electrons and the nucleus were unknown. So That is why Dalton's model is just a fear with nothing. It is because most of the things were not discovered about the atom. Thomson came up with his plum pudding model. He first discovered the electron. So discovering the electron helped him propose this model, and it made other scientists realize that the atom is actually made up of even smaller particles than previously thought. The model shows that the atom is made up of negative electrons that float in a soup of positive charge, much like plums in a pudding. So as you can see in figure 4.2 below, we have the soup of positive charge, so the huge positive charge that you see, and then we have electrons around this soup of positive charge. The electrons are floating around this positive charge. That was Thomson's model. Then Rutherford first performed a gold foil experiment that he based his atomic model theory upon. And this gold foil experiment that he conducted actually showed the scattering of particles. So in his experiment, he aimed a beam of positively charged alpha particle, which are helium ions, radiated by a radioactive element. So during this time, Marion Curie had already come up with the radioactive theory, which made it easier for Rutherford to do his gold foil experiment. So he aimed this beam of positive charge alpha particles at a very thin piece of gold. So as you can see in figure 4.5 below, we have a gold sheet, and then this gold sheet is the very thin piece of gold that was used by Rutherford. A fluorescent screen was placed around it to indicate the path of the alpha particles. As you can see, the fluorescent screen, which is the zinc sulfate screen in figure 4.5a. And then what did Rutherford discover in his gold foil experiment? Rutherford discovered that most of the alpha particles passed straight through the gold foil. So he then concluded that most of the atom consisted of empty space. So as you can see in figure 4.5b, the arrow labeled A, we have particles passing through the gold foil. So then Rutherford came up with a conclusion that, okay, it means that the atom consists of empty space, since the particles were able to pass through. And he also discovered that a small number of alpha particles change direction. As you can see, the arrow labeled B in figure 4.5b. The arrow labeled B, you can see that they do pass through, but now they change direction. And he also discovered that a few scattered backwards. As you can see, the arrow labeled C, they do not go through. So from these two, he concluded that at the center of the atom, there's a small atomic nucleus that contains all of the mass and positive charge of the atom, which would cause the scattering and the changing of direction. The scattered alpha particles were repelled by the positive particles in the atomic nucleus. Then Rutherford came up with his atomic model based on the gold foil experiment. His model described the atom as a tiny, dense, positively charged core called a nucleus surrounded by lighter, negatively charged electrons. And another way of thinking about Rutherford's atomic model is that it's a mini solar system where the electrons orbit the nucleus like planets orbiting around the sun. So the nucleus is like the sun, and the electrons are like the planets that orbit around the sun, as you can see in figure 4.3 below. So you have the electrons orbiting the nucleus, and you have the nucleus at the center. That is it on this video. On the next video, we are going to continue looking at atomic models.